So in this video we are going to learn about the mixed grouping of cells. So what is the meaning of mixed grouping of cell is that first we write down the mixed grouping of cells. So this is the thing. So here we all take we take all the cells are identicals. So mixed grouping of cells means we consider of identical cells of each of EMF E and internal resistance small r. So let this cell be arranged in m rows and each row contains the end cells. So we are going to draw the diagram for this type of thing. So this is one cell here, internal resistance, another cell like this way, a number of cells will be there. Here we put a dotted line so that you can see several number of this type of things are repeated. So that is why a dotted line is there, and then so this is E R E R. Okay. So now end cells are there. N number of cells, and in this side the total number is m. So m rows. M rows and n cells are there. Now it's connected here with the external resistance R is there. So like this way. Resistance R, I current is passing in this direction. Like this. So now same thing, you will get the equivalent of this one to look like this. Equivalent. We'll find out what is the value here. Instead of this whole setup, we're going to find out this R like this. So whatever the value will come, I don't write afterwards after calculating, after finding out this one. So now the total EMF of n cells in row. So you can write total EMF of n cells in a row will be how much? Will be equal to NE. Okay. So total internal resistance will be also so what and m rows are there. So since m rows are connected in parallel, so the EMF of cell in the row will be equal to that means what? Right, since m rows are parallel to one another, so net EMF of all cells in the combination equal to EMF of cells in one row. Okay, so then what we can write? We can write that E effective is equal to N into E. Okay, and the same case, N cells are connected in series, so therefore internal resistance of N cell in row, so internal resistance of how many cells? N cells. So N number of cells are there, N cells in row is equal to N into R. So like this way, how many rows are there? M number of rows are there. So you can write R effective is equal to 1 by NR plus 1 by NR. So in this way up to M. Okay, so you can write is equal to M by NR. So R effective is equal to NR by M. Okay, so you can write it here. So this will be how much? This will be NE, and it will be NR by M. Okay, so this is the thing. Now we can understand that one external resistance is connected here. So total resistance, you can write total resistance is equal to NR by M plus R. So current in the circuit will be I will be equal to total EMF is NE by total resistance is R plus NR by M. So if you can solve this one, you will get MNE by MR plus NR. Now you can arrange this one in such a way that I will be equal to MNE by root over MR minus root over NR whole square plus 2 root over M N R into capital R. Okay, so if you can split into like A minus B whole square formula, you can get this value. Now the current in the circuit will be maximum. So right, current will be maximum. I will be maximum. See, I think so. I will be maximum if root over MR is equal to root over NR. So in order to get the maximum current in the circuit, the mixed grouping of the cell must be done in such a way that the external resistance is equal to the effective internal resistance of the cell. So you can remember this one. Okay, so in order to get the maximum current, what I told you, that the grouping should be done in such a way that the external resistance is equal to the effective internal resistance of the cell. Okay, so that means what? If this one is root over MR and NR, then R will be equal to NR by M. No, NR by M. Okay. to internal resistance of a mixed grouping cell. Write down internal resistance of mixed grouping cell. So now generally the series combination of a cell is used when the high EMF is required. The parallel combination of the cell is used when the high current is required in the circuit, and the mixed grouping of cell is used when high power is required in the circuit. So that's all here. So next class we'll continue with the potentiometer. Okay, so thank you very much.